Greetings and salutations, mathletes. I apologize for my absence. I'm at a very exciting math conference right now. I hope that the quiz went well for you and you were well prepared from what I told you in class and the practice quiz. I'd like you to think about these three questions for me. I want to know, how can I show that these two triangles are similar? What is the ratio of the scale factor without numbers? And then finally, if these are coordinates of a point, what would it be after the origin? Please pause the video and give it a shot. Okay, so in both of these triangles, we have one set of congruent angles and then a set of vertical angles. So this would be angle-angle similarity. And it says, what would the statement be in part A? So this is where we have to be careful that we're using corresponding parts. So E would correspond to B, C would correspond to C, and D would correspond to A. The next one was like the quiz question. If we're going to this, this is my image, this is my pre-image. I divide the pre-image. I'm going to use WX, and this side would correspond to AB. And that would give me my scale factor. And then the last question, if I have this point and we're rotating around the origin, I would multiply this by 1/4. And A prime would be 3, -6. Okay, so the first thing that we're going to do is we're going to finish up a proof in our packet that we didn't get to. Okay, so I'm on page 29. All right. Um, there are 3 steps at the end of a similarity proof, but the good news is we only need angle-angle similarity. So the tricky part is the given gives me some information. I have to know what an altitude is, all right? And the prove is showing me the step after a proportion. So if I look, here's E to R, okay? If I highlighted SD, I wouldn't be able to make a triangle out of that. But TE with E to R makes that triangle. And then SD and DT make that triangle. Okay, so we're trying to find 2 sets of angles that have to be congruent in those triangles. I would like you to pause the video and from the given, see if you can determine that. Did you pause it? You should pause it. All right, so the first given tells me about this whole triangle. S to R and R to T are congruent. And that would tell me that this angle, I'll call it angle 1, and this angle, angle 2, are congruent. So 1 is in the blue triangle and 2 is in the green triangle. Secondly, I'm told that these are altitudes, okay? So first thing I need to know is from an altitude, altitude tells me perpendicular, perpendicular forms right angles, and then right angles are congruent. All right, so most of you are used to saying perpendicular forms right angles and right angles are congruent. We're just adding to that. So I'm going to call this angle 3 and that angle 4, okay? And that's going to be my 2 sets of angles for angle-angle similarity. The last thing that I want to talk about, just getting set up, is there had to be a proportion that made this happen, okay? And when we solve proportions, I hope you didn't say cross multiply too loud in front of everyone, but to solve a proportion, we will cross multiply. All right. So if I'm looking at the prove, these two have to be diagonal from each other. So ER has to be diagonal from SD, and then these two have to be diagonal from each other. TE has to be diagonal from ET. Okay, so in building it, these are my suggestions to you. Okay, we've never seen a congruence proof that ends with things multiplied together, so that tells us it's similarity. All right, so I'm going to write out some of my steps. Okay, hopefully you can fill in some of the missing reasons. Hopefully you're even watching this. Hopefully if I told you this is like the 6-point problem on our upcoming test, you believe me and would practice. So try and build it yourself, pause it, and I will be right back. All right, and welcome back. So I've listed out some of my statements. I'd like you to fill in the missing reasons for these. Okay, and the main goal is I want to have two sets of congruent angles. So right here, this would be my first set of congruent angles. Right here, this would be my second set of congruent angles. So that would allow me to state that my triangles are similar by angle-angle similarity. All right, so I'd like you to pause. I want you to figure out the order in which we put the letters for the triangles and what are the missing statements here, and then you can resume to see how you did. All right, so looking at this, in red it says the legs of a triangle are congruent, the base angles are congruent. You could have said if two sides of a triangle are congruent, the opposite angles are congruent. 3, the word altitude of a triangle is perpendicular to the opposite side. 4, perpendicular forms right angles. 5, right angles are congruent. 6, angle-angle similarity. And if you're getting all of those right from Despicable Me, oh yeah, you have some direction and magnitude, but no vectors right now. All right. So if I'm going back, all right, if I picked, and which color did I use? So if I pick TER, awkward. So if I pick TER, okay, now I got to figure out for my green triangle which one's the same. Okay, so if I started with T in the blue triangle, I would have to go with S in the green triangle because T didn't have a congruent mark. So this would start with S. And then E had a right angle for blue. That means D for the green triangle. And then R corresponded to T because those both had right angles in them. Or congruent angles, excuse me. A little visit from the custodian. I asked him if he wanted to be a guest speaker for this proof. He declined. All right, so now I'm going to put my proportion. This always comes after if I have to go farther for similar triangles. So we said ER to TE, and then DT to SD. Again, we built that because they're diagonal from each other. Some people will use the acronym CSSTP. Okay, or you can say if triangles are similar, then corresponding sides are proportional. If you need to know, this means corresponding sides of similar triangles are proportional. So that's how we work through that. And then number 8 is my proof. ER times SD equals DT times TE. And I would accept cross multiply. Some people write the product of the means equals the product of the extremes. Okay, and that's as hard as a proof as it can be. I'd like to reiterate this is probably the 6-pointer with different letters. Okay, but proofs always end. The triangles are similar, angle-angle similarity, a proportion, CSSTP, or they end with cross multiply. All right, So the rest of the class, we're going to practice doing some solving for missing sides of similar triangles. Okay, part of this is going to be a little confusing, so at any time you can pause and go backwards. All right, so we're starting out knowing some things are parallel. So D to E, A to C are parallel. Okay, they tell me BD is 6, BE is 4. That's giving me two sides of that triangle. They tell me E to C is 4, which is giving me like a piece of the bigger triangle. Okay, but I'd like you to stop and figure out, like, why are these two triangles similar to each other? If you haven't stopped yet, my hint to you is it has something to do with parallel lines. Okay, so we could either have alternate interior, corresponding, alternate exterior, or same side interior. So I numbered my angles. All right. Um, if I know that these two are parallel, then 1 and 2 are technically in the same position. They both be top right. And then 3 and 4 are in the same position from a different transversal. They're both top left. Okay, so if I have parallel lines, then corresponding angles are congruent, which would lead me to angle-angle similarity because we have two sets of congruent angles. Once we know that, they want us to figure out what is the value of side DA. Okay, so I would use the big triangle BAC, all right? And if this is x in the big triangle, this is going to be x plus 6. And then if this is 4, apparently I wrote an E there instead of an 8. So I add those two together, I would get 12. Okay, so I'm going to set up a proportion to solve this. And I could use the two sides of the small triangle, 6 to 8. And then I'd want to use x plus 6 because that's the same as, or corresponds to that side 6, and then 12 down here. So I need to pause the video, cross multiply, and solve. All right, and hopefully as you were dominating this, we cross multiplied. Don't forget this part right here. We're going to need to distribute when you have a binomial or a polynomial. We're going to need to distribute. Okay, so make sure you have this 48, and 24 divided by 8 is 3. Okay, so this was tricky because we had to add some sides together to get the whole thing. Now, at the bottom of this page, okay, here's a theorem that someone proved, all right? And it says if a line is parallel to one side of a triangle and it intersects the other two sides, the line divides these two sides proportionally. So here's my triangle. If this line is parallel, okay, in the top triangle, I'm going to call that side A and that B. And then these two pieces I would call C and D, all right? I can set up a proportion, and typically we call this the side splitter theorem. Okay, because this parallel line splits the sides. So I can do A over C equals B over D. Okay, and if I compare that to the last problem that we had, all right, A would be 6, C would have been X, and then we have an 8 and a 4. And if I'm solving this, 8x equals 24 divided by 8, I get x equals 3. Okay, but you have to be really careful. You have to know that these are parallel, all right, and you have to use the sides that have been split in order for that to happen. So this leads us to our key concept. All right. Again, same thing. If a line is parallel to one side of the triangle, intersects the other two sides, it divides it. Okay. So AB is in the smaller triangle, and then BD is our like pieces. So then I'd go back to the smaller triangle with AC, and then the piece CE. Okay. So here's my caution. All right. You cannot set this equal to BC over DE. You cannot do that. Okay. So you can't use the pieces and then set them equal to uh, the sides. All right. So one rule is do not use the parallel sides unless they're given to you. Okay. With that said, all right, you're going to have to determine, do I have side splitter or not? So the first thing I see is parallel. So that means I could use this top triangle and the bottom triangle are similar to each other. And they're telling me SL is 4. And then this piece LR is 3. SM is 6. And they want me to find MT. So this is side splitter. I'm not using the parallel sides. I would like you to pause the video and try and set up a proportion. Pause it. Why not? You won't. So your proportion might look differently than mine, but you did it correctly if the 4 and the X or whatever we're looking for is across from each other. And then if the 6 and the 3 are across from each other. Okay, so then I would divide off of 4. And this little segment right here is 4.5. And you just have to be careful. They ask me for the whole segment, just a piece of it. All right, just reread it so we know what's going on there. And we are chugging right along. We're still on page 31. All right, so this is where it's going to get a little bit more exciting. They tell me AD to EC is in a ratio, and then BE is going to correspond with EC. Okay, so they're saying like AD to EC or AD over EC. They're trying to get you to see this in a different way. Don't get too thrown off. So A to D was 2x minus 4. E to C is x. They're telling me DB is 18 and BE is 24. I saw parallel. Okay, so now I know that top triangle is similar to the big whole triangle. But then I could set up my proportion and try and solve it. Please do so. Remember, pause the video anytime you want. Go back. All right, I got 3.2. I reread it. It says find E to C. E to C is labeled with an X, so I'm done with that. All right, don't forget to distribute. So this part right here, we have to make sure we distribute the 24. Okay. So again, that was side splitter because we had the parallel lines and we were dealing with the pieces of them. Now, in this problem, they tell me these are on a line. So all that means a collinear, perpendicular, I have a right angle there, perpendicular, I have a right angle there. Okay, these are corresponding. If they're corresponding, I can then prove that these lines are parallel. So that's not too different. And then they gave me some missing pieces there. All right, but you'll notice the 9 and the X are sides of the triangle. So those are the parallel lines. So I'm using that triangle and this triangle. Okay, I can't set up a proportion with the 8. I have to add these two together to be 20. All right. If you want to be safe, always add them together. But then I could set up my proportion. And as long as the 12 is across from the x and the 20 is across from the 9, then we can solve it from there. I reread the problem. What's it asking me for? It wants me to find the x. I found x. There it is. Look, find x. There's one. Okay, we're now into number 4. So they hit me with parallel. I know all about parallel. They tell me AC is 10 and DE is 4. So as soon as I label those, this is not side splitter. Okay, then they tell me D to E, nope, B to D is 6. And they want me to find A to D. Okay, so I think we have one like this on our test as well. I'm gonna have to add these together to set up in my proportion because I have to use the big triangle to use the 10, and then the smaller triangle, I'm going to use the 6 and the 4. So go ahead and set up your proportion and solve. All right, so again, as you're looking at my work, okay, x plus 6 and 10 were out of the big triangle, and then 6 and 4 with their corresponding sides in the small triangle. As long as the 6 and the 10 are across from each other, as long as the x plus 6 and the 4 are across from each other, you're good to go. Okay, but this is the hard part of similarity. Do I have to add the sides together or do I not? I reread it, find AD. AD had an x on it. I have solved it. I am done. It's also good to think about it at the end. Okay, 4 goes to 10, then 6 goes to 15. You could figure out its scale factor. All right, so I'm going to pause here. I would like you to try and set this problem up and then set up an proportion in order to solve it. We're trying to determine, do I have side? All right, so I'd ask in class if this is side splitter or not. Might be a couple crickets. Awkward pause, good. And we have the parallel lines, okay? And they're giving me the pieces from it. So this is side splitter. I could do x plus 5 over 2x plus 6, and then back to the small triangle, x minus 1 over x. So this one is going to bring us back to algebra. I am going to cross multiply that. And I'm going to cross multiply this. Okay, so some people double distribute to multiply two binomials. Some people use the box with an x minus 1 and a 2x plus 6. So 2x squared, negative 2x, 6x, and negative 6. So I'd have a 2x squared, positive 4x is what this diagonal would add to, minus 6. And here I'd have an x squared plus 5x. Then I wonder to myself, well, how do I solve this? And I see squared, so I need to set it equal to 0. I like to keep my x squared a positive term. So I subtracted to the right. So I'd have 1x squared minus 1x minus 6. Now some people might think, all right, what adds to negative 1 and multiplies to negative 6? Okay, if you're going to use the box, you can use the box. I'd have x squared, negative 6, and negative 1x. Okay, my choices are 1 and 6 or 2 and 3. If I'm multiplying to a negative and adding to a negative, the bigger numbers are negative. And 2 and negative 3 would accomplish my task. So then I would set these equal to 0, which switches their signs. Okay, and I go back and I reread it. They want to know what's G to C. And if I did negative 2 minus 1, I'd get negative 3, which makes no sense to have a negative length. But if I did 3 minus 1, which equals 2, that might not be the most exciting answer. All that work for 2. Oh, but that's the way the cookie crumbles sometimes. All right, so I graphed these two triangles because it told me to plot them. And it says find the length of all the sides and label them in your picture. So I did a little counting and I found that this was worth 9, this was worth 12, and by the Pythagorean theorem, I can determine the third side. Okay, and then in the smaller triangle, this was side 3, this was side 4. I know that 3, 4, 5 makes a right triangle, so I didn't do the Pythagorean theorem there. But now I can see that this would probably be 15 because it's the square root of 225. Okay, so we have to be careful. They want the ratio. They put in the smaller triangle on the top and the bigger on the bottom. So 3 over 9 could work. It ends up being 1/3 or 0.3 repeating. Okay, so they want the ratio of the perimeters. So we got to add up the perimeters. So 9 plus 12 plus 15. I got 36. And then 3 plus 4 plus 5. I got 12. And I noticed that these are the same. Okay, and hopefully that makes sense. We're adding them up. The perimeter and the sides would have the same scale factor. Now, area is a little bit different. Okay, so area of a triangle is 1/2 base times height. So for the blue triangle, I would have to do 1/2. The base is 12 times the height of 9, and this would give me 54. For the smaller triangle, I'd have to do 1/2. The base was 4 and the height was 3, and this would give me 6. Okay, so if I'm comparing their areas, I would do 6 over 54. All right, and if I put that in my calculator, I can figure out, I don't have my calculator up on my page, but if I put in my calculator, this would simplify to 1/9. Okay, so there's a correspondence between 1/3 and 1/9. It's probably easier to see 3 to 9. All right, but if we're talking about the area, we're really going to do the scale factor squared. Okay, because that scale factor would incur twice in that formula with multiplying. Okay, so 1/3 squared is 1/9, and that's usually a multiple choice question for us to go through there. Okay, so two polygons are similar. The ratio of the perimeter is equal to the ratio of the sides. All right. If it's area, all right. If I was talking about area, I'd have like square feet or square centimeters, square miles, something like that. Hopefully that helps you remember you want to square that ratio. So they get tricky with it a little bit and they would ask me something like, okay, so I've got these two similar triangles. And they tell me AB is 15 and DE is 12, and those two sides are corresponding. But they tell me the perimeter of ABC is 40, so that adds all these up. And they want to know what is the perimeter of DEF. Okay, so because they have the same scale factor for perimeter, I can set these up in a proportion. If it was area, I'd have to square the scale factor in the proportion. So I could do 15 over 12 and then 40 over P. All right, I got a perimeter of 32. Hopefully if it was multiple choice, This triangle, the blue triangle is bigger. You'd pick something smaller than 40. All right. Um, but that's a big idea for right now. Okay. I think this is where I'm going to stop. Please get the homework. All right. And I will see you on Monday. Thank you very much for listening to this, and I hope it wasn't too painful. Stock money out.